Okay, so this is the video clip for the second problem in the 1-2 rate of motion velocity discussion. And the second problem says, how far can a cyclist travel in 2.5 hours along a straight road if her average velocity is 18 kilometers per hour? Okay, so you can probably easily think I'm going to just multiply 2.5 hours times 18 and get the correct answer, and that's certainly true, but I need you to follow a pattern of activity that's going to result in you always being able to do these problems no matter how complicated they actually get. Okay, so here's how we're going to do this. Again, we're going to start by using our motion diagram. We'll create this like this. We always have an origin, and we always have a direction of positive values. Okay, now in this case, we aren't really told much of anything else. I want to collect all of my information, but I'm not told any information about positions. Okay, so when that's the case, I'm always free to say my initial position x0 equals 0 meters. Okay, and I'll usually use x0 for my initial position. x0 equals 0 meters. But I haven't been told how far I'm going to go. What's my final position? And that means I can just put a question mark there. And in fact, that will be our needed value, right? Then we're told we have an average velocity of 2.5 kilometers per hour. Okay, now in this problem, it doesn't make any difference, but sometimes we'll want to change that into meters per second. But in order to show that this is a constant velocity, or at least an average velocity, I don't know what the velocities in between or during the whole thing are, but I'm just going to say that my velocity looks like this. Okay, I'm going to pretend that it's constant the whole time through at 2.5 kilometers per hour. Okay, and again, I don't have any information about acceleration. And we see that it's actually 18 kilometers per hour, right? Not 2.5. 2.5 is the time. So 18 kilometers per hour is my velocity. Okay, and we're not given any other information, so we don't really need to write all that stuff down. So we say that our given information is x0 equals 0 meters. My needed value is x, and then I was also given that my average velocity or velocity is 18 kilometers per hour. Okay, so do I know a formula that can help me find this answer? I want to know how far I went, and I'm still going to use the same formula, the velocity formula, v equals delta x over t. Okay, but in this case, and we're going to start a new tradition here for you in case you're not used to this kind of thing, we're always in our problems going to try and isolate the variable that we want before we plug values in. Now, you certainly, if you want to, can go ahead and put 18 kilometers per hour in there and put 2.5 hours in for time, which I should have put in my given list. Okay, but I want to show you that isolating the variable that you want or getting it by itself before you plug values in, at least in more complicated problems, is going to be a better way to go. In simple problems, it doesn't really matter. I could just say, if I wanted to, 18. If I wanted to solve this way, I could just say solve, and then plug in 18 kilometers per hour equals delta x over 2.5 hours, and then I can multiply that by 2.5 and find out what that was. But I want to do this. I want to first multiply both sides of the equation by t, and that makes it so that, let's get rid of that little bork there. That makes it so that delta x is velocity times time. And now we get a better understanding by looking at this of how I can find how far I went if I know velocity and time. I can go this far if I have this velocity and this time, and so now I can come over here and say delta x equals 18 kilometers per hour times 2.5 hours, and that's going to be 45 kilometers. Okay, so it doesn't matter to me. You can continue to do problems where you plug values in before you isolate the variable that you want. I'm going to make it a habit of showing you how to isolate the variable and then plug the values in to get my answer. We get the same answer in both cases, right? We get 45 kilometers. But I'm going to show you that this way of doing things ultimately is easier and more effective at preventing mistakes. Okay, so this is the end of the discussion for this second problem. Okay, go ahead and go to the next one.